This is part 7 of section 2.3. We're just going to push ourselves a little bit. So we're going to work 2 problems that are harder. First of all, we want to show that there is no real number a such that x squared minus 1 is a factor of x to the 10th plus ax plus 4. Okay? Now, if it is a factor, then that means it divides evenly, so our remainder is 0. So basically what I want to do here is to do the division. I want to see if there's a 0 remainder. So basically, I've got x to the 10th plus ax plus 4, and I want to divide that by x squared minus 1. Now, you can do this with long division if you want to. I cannot use synthetic division in this form because of that square. But you may recognize that this is a difference of squares, and that will make it easier. So go ahead and factor that. And this is x plus 1, x minus 1. Now, what this means is that if I divide by x plus 1, I need to get 0 as a remainder. If I divide by x minus 1, I also need to get 0 as a remainder. So whatever a value is, it has to work for both of those. If I get 10 when I divide this, if a has to be 10 here and then a has to be 15 here, there is no a that will work. If they both end up being 2, it works. Okay? So I'm going to do this synthetic division, and there are a lot of zeros I need to put in here, but let's just see where we end up. So first, I'm testing -1. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You should always have one more than your degree if you want to check. The arithmetic's going to be tedious here, but easy. So bring down the 1, and you're just going to have a whole bunch of 1s and -1s for a while. Okay, so here I have a minus 1. And now multiply, and you get -a. You get -a plus 1. And now add these, and you get -a plus 5. Now for this to be a factor, then my remainder needs to be 0. So if I set -a plus 5 equal to 0, a has to equal 5. Okay, so if a is 5, this is a factor. And that's the only a that will work. So when I test this one, if my a value has to be anything else, there's no a that will work. So let's do that. Okay, now this one is even more tedious because we're not even going to get to change from positive to negative. It's just going to be a whole bunch of 1s. And now I have a plus 1, which is a plus 1. And now add, and I have a plus 5. That's my remainder. I need to set this equal to 0 to figure out what a value would work. And you get a has to be -5. This one requires that a is 5. This one requires that it's -5. So we don't have one a value that works for both. So that's a contradiction. Okay, so let's look at this one. We want to find all rational roots of 2x to the fourth plus 2x cubed plus 1/2 x squared plus 2x minus 3/2 equals 0. Roots, zeros, they mean the same thing. So I need to list my possible zeros, and then we'll go from there. But the problem is, if you look back right here, we have to have integer coefficients, and we don't. Okay, so how do we deal with that? We're going to multiply both sides by our least common denominator. In this case, we have two fractions. They both have a 2 as a denominator. So I'm going to multiply this entire equation, every single thing in there, by a 2. Okay, so I get 4x to the fourth plus 4x cubed plus x squared plus 4x minus 3 equals 0 times 2 is still 0. Okay, now that I have it in this form, I can find my p over q and I can work it the way we've been doing it. Okay, my p-values come from the 3. Okay, my q values come from the 4, so plus or minus 1, plus or minus 2, plus or minus 4. So my p over q values, 1 over 1, 1 over 2, 1 over 4, 3 over 1, 3 over 2, and then 3 over 4. Okay. This was the main point of this problem, so I'm going to make some good guesses since I have the right answer here, just to make this go a little bit faster. So I'm going to check 1/2. Okay, 1/2, I need to use these coefficients when I set up my synthetic division, and every term is there, so I'm good. No zeros required. Okay, now I'll bring down the 4. 6, 3, 4, 2, 6, 3, and that's a 0. So one of my solutions is 1/2. I probably have more. Don't know. Okay, so let's look at what we have right here. Write down this depressed equation. Well, this was a 4th power, so this is a 3rd. So I have 4x cubed plus 6x squared plus 4x plus 6, and I want to set that equal to 0 and solve. Okay, well, I can keep going. Or, like I said earlier, I generally look to see if something will factor. And every single thing here is an even number. So even if I don't go any further with this, I'm going to simplify this by dividing every single thing by a 2. Because my numbers will be smaller, my p over q values will be smaller, everything will be easier. So I get 2x cubed plus 3x squared plus 2x plus 3 equals 0. Also, like I said earlier, I generally look to see if I can see quickly how a cubic equation might factor. When you have 4 terms, you look for factoring by grouping, and it turns out that factoring by grouping does work on this one. So let's group. I can factor x squared out of my first group to get 2x plus 3. And because I want to factor something out, I'm going to factor out a 1. Okay, so this factors as 2x plus 3 times x squared plus 1 equal to 0. Now set each of these equal to 0 to get your other solutions. Here you get x is equal to negative 3/2, which was one of my possibilities. Okay, now set this one equal to 0, and you get x squared plus 1 equals 0. X squared is equal to negative 1, which is going to take the square root of both sides. And we're not dealing with complex answers, so this gives us no rational solutions from this part. Okay, so these are our only two rational solutions.